This is the next in the series of video shorts brought to you by Bristol Ground School. My name's Ali Sinclair, and today we'll be looking at the direction indicator, or DI. This instrument is also referred to as a heading indicator and sometimes called a directional gyroscope, DG. This video covers the DI, and I will refer to it as such simply because that's how it's referred to in the PPL and the ATPL learning objectives in Part FCL. Now, the DI uses the principle of gyroscopic rigidity to remain aligned with the aircraft's heading and therefore measure changes in the heading relative to the Earth's surface. It has two gimbals and therefore 2 degrees of freedom. But one of these degrees of freedom is tied to the aircraft's horizontal plane. More about that later. A reminder of the principle of gyroscopic rigidity. A rotating gyroscope will remain fixed in space unless acted upon by a force, regardless of the orientational movement of the aircraft. Let's have a look at a schematic of the DI. The gyroscope is mounted on the inner gimbal and has a horizontal axis of rotation, meaning that the mass is mounted vertically. The outer gimbal is fixed to the instrument's case and hence to the aircraft itself, but is free to move rotationally, and therefore the aircraft moves around the rigid gyroscopic mass, which remains fixed in space. The angle through which the aircraft has turned is mechanically fed to a vertical display in the cockpit by a series of connecting gears and rods. In earlier designs, however, the display was similar to that of a magnetic compass. A later version of the cockpit instrument design is shown in the next image. It consists of an outline diagram of an aeroplane with the nose pointing in the direction that the aircraft is heading. The display is also annotated with red 45-degree marks increments around the dial to assist with reading off of angles. Glass cockpit presentations are visually very similar to those in more traditional steam-driven gauges. You'll notice that I have not mentioned the word magnetic in the context of the DI. And that's because this instrument is not sensitive to the Earth's magnetic flux at all. The pilot is provided with a knob at the bottom left of the instrument, which is used to align periodically the DI with the aircraft's magnetic compass. The fact that the DI does not indicate direction, at least not with the help of the compass, begs the question, why doesn't the pilot just use the compass? Well, that's because the magnetic compass itself is subject to acceleration and turning errors, meaning that the compass reads incorrectly when the aircraft's turning, arguably just at the point when the pilot most needs an accurate indication of the aircraft's heading. The DI, however, reads accurately throughout the turn, as long as it's been aligned with the compass, of course. The DI is a tied gyroscope. A tied gyroscope is a gyroscope that's one of its gimbals held aligned with either the aircraft's vertical or horizontal axis. In the case of the DI, the axis of rotation of the gyroscope is tied to the aircraft's horizontal plane, and thus the rotating mass is held perpendicular to the aircraft's horizontal plane. This is done by a rather clever system. Earlier, I mentioned that the gyroscope is driven by air, drawn across a set of buckets by a vacuum pump, actually. Let's have a closer look at that. By the way, this animation uses an earlier DI design just for simplicity. The air is fed through nozzles that are mounted on the outer gimbal, which is itself physically connected to the aircraft's horizontal plane. When the gyroscope mass is perpendicular to the aircraft's horizontal plane, the air is blown symmetrically across the buckets. As the aircraft pitches and rolls, the gyroscope mass moves away from the perpendicular, and the air then hits these buckets asymmetrically, resulting in a correcting force being applied to the mass, which returns it to the perpendicular. The fact that the DI reads accurately in the turn does not mean that it doesn't have a few of its own foibles. In the next video, we'll have a look at the errors associated with the DI. Toodaloo!